Have you ever wondered what keeps a train coach comfortably cool during the scorching summer? If you take a look at the roof of any modern train coach, you'll likely notice sleek, self-contained units mounted on top. This is the roof-mounted package units, RMPUs. Just imagine how these giant machines provide such comfortable temperatures inside the coach. In this video, we will explain the technical parts of an RMPU and how they work together to cool the coach, ensuring a pleasant journey for passengers. Every coach is typically equipped with two of these RMPUs, one on each side of the roof, ensuring robust and redundant cooling capacity. Now looking at the air distribution, the middle channel is for cooled air supply, while the channels on both sides are for the return air that comes back from the coach, which then enters the AC units for reconditioning. If we open one of these AC units, you'll observe there are 6 compartments within the RMPU. The left and right sections house an identical set of components. This is the condenser. You'll notice these are located on both sides of the AC, positioned to dissipate heat effectively to the outside. These are condenser fans. They are used to pass heat out from the condenser. This large component is the compressor. It is truly the heart of this AC system that pumps the refrigerant through the system. This component here is the accumulator. Its main job is to protect the compressor. This is dryer. This component here is the expansion valve, a key part of the refrigeration cycle. Next, we have the blower setup, which includes the powerful blower fan itself, driven by its dedicated motor. Just in front of the blower setup, you'll also find the heater coils. These are responsible for providing warmth inside the coach during the winter season. On both sides of the blower, you'll see the cooling coils, or evaporator coils. And right in front of them are the air filters, essential for keeping the air clean that circulates inside the coach. Now, to understand the operational cycle of this AC unit, we begin with the compressor. This component compresses the refrigerant gas, which significantly increases both its pressure and its temperature. This component here is the accumulator. The hot, high-pressure refrigerant gas flows into the condenser coils. As the hotter refrigerant comes into contact with the cooler air, it releases its heat to the outside environment. The high-pressure liquid refrigerant then travels to the dryer. This component's main job is to remove moisture and contaminants from the refrigerant. Then it comes into the expansion valve, sometimes called a thermostatic expansion valve. This valve creates a precise restriction, causing a drop in the pressure of the refrigerant. This sudden pressure drop also causes the temperature of the refrigerant to plummet, making it extremely cold, often well below freezing. Then, the extremely cold, low-pressure mixture of liquid and gas refrigerant flows into the evaporator coils. As the warmer air passes over the cold coils, heat from the air is rapidly absorbed by the refrigerant. This absorbed heat provides the energy for the remaining liquid refrigerant to boil and turn completely into a low-pressure gas. This process of absorbing heat to change phase is what creates the cooling effect. As the warm, humid air cools rapidly, moisture in the air condenses on the cold surface of the evaporator coils. This water then drips into a drain pan. After that, the cold air enters or delivered by the blower. After leaving the evaporator as a low-pressure, low-temperature gas, the refrigerant returns to the compressor, and the entire cycle repeats continuously. If you think this video is helpful, share your best comment to inspire more content. Thank you. Let's grow up. Never stop learning.